basically that is the conversation to have now. What is the solution to having a big problem where you don't have enough compute running through a simulation on one machine to be able to do that? And that's what I want feedback from you guys from, really.
So unfortunately, I missed your presentation yesterday, but my presentation yesterday was about a similar topic of how you can support the compute needs of the metaverse with edge computing and edge networks. And I don't have the answer, by the way. Don't lean forward. I'm not going to provide the answer, but I'm sensing that we're just dealing with an issue of limited resources, and we just shift around the problem, but we're not really solving it because we want to do more on the edge devices, whether it's the end devices or edge computing close to the end user, but at the same time, those devices are resource constrained and they're not ubiquitous as we want them to be, at least the edge computing. So I think my kind of prediction is that at the end of the day, it will be a combination of processing at the end device, edge computing, the cloud, and we need to somehow provide a very reliable connection between them. So is it something that you guys are thinking about, like combining different types of compute power?
Oh yeah, absolutely. So the way we envisage it is you have your central simulation, your simulation where everything happens, and that can have your tens of thousands, hundreds of thousands of people in there. But if you've got one simulation with lots of stuff happening distributed across lots of machines, you then have the problem of all this data having to fly between different machines to process this simulation. And then you've got the people on the users that are connecting to it, and they suffer from lots of lag, lots of latency because they can't get all that information as quickly as they possibly can. So to deal with that, we then use edge servers off the back of that to start looking at what actually the people who are connected to that edge server need to know. So you don't need to have the entire simulation state in your edge server, just the bits which the people who are connected to it need to know. Then you can start running processing on the edge server as well, sending the deltas back to the main simulation so you can still have all the connections happening between it all. Is that how you see?
It's probably inevitable to do it that way. My concern, and I'm kind of projecting from previous experience, that when you start having all those options of where to do the computation, it's getting out of control, so to speak. So just controlling and deciding what to run where and what kind of assets you have. And so I was wondering if it's something you ran into. So when you add these edge devices, how do you know how many devices are available, how many resources are there, how you decide what to run on the edge device, what to run centrally? Do you feel you're in control, or is this posing a new type of challenge to just know what resources you have?
No, I mean, it's definitely a challenge. The way sort of we look at it is you need to think about what information you need quickly and what information you don't need quickly. So when I'm the end user, what do I need to know straight away? What don't I need to know straight away? If I need to know what's immediately around me, that's the sort of stuff you want to keep on the edge, because that's the stuff I need to query very quickly, get that information back. Because your latency that you've got to work with is less than 100 milliseconds before people really start complaining about that experience. So that needs to sit on the edge server. What's immediately around me has to be there. The processing of what you do with that information can happen in different places. So for example, I want to talk to that person who stood just over there. I'm going to send them a message. That message doesn't have to go directly to that person. That can go somewhere else, get processed by a message server, run through whatever moderation systems you have, and then come back, because that can take 200, 300 milliseconds to do, because that's not an immediate problem. But if I want to shoot that person, that needs to be processed straight away. Or do something nice to them, like give them a flower, let's say. That has to be done straight away. So that has to be processed right on the very edge in order to happen as you would expect to happen. And that will change simulation to simulation to simulation, depending on what your aim is. If it's a first-person shooter, obviously your shooting goes right on the edge because that needs to happen straight away. If you're not, then that doesn't need to be there.
So interesting. So you're saying that your decision on when to run the task is based on basically the issue of latency or round trip, which is one dimension.
Yeah.
But there could be other constraints, like you may not have the edge resources where you need them, so one player may be at the remote location where you don't have that capacity and you don't have a choice. I mean, do you see it as a simple issue of making simple decisions on where to run the process, or I could imagine having multiple dimensions of constraints, like timing that you mentioned is one of them. The other could be compute resources, other, I don't know, if there could be other things, like where is the data allowed to be? I mean, maybe it's not applicable to multi-person shooting games, but you know, maybe I can have the data traverse some remote network because of some legal constraints. So I'm wondering if you kind of agree that it might blow up into a multi-dimensional constraint problem.
Everything can be multi-dimensional. The way our technology works is we can set what machines we want to happen and automatically spin up those machines. So if, for example, we're seeing a whole bunch of people connect from one country, we can then spin up machines, so more edge servers in that area in order to connect that. So the actual compute problem and the resource problem seems to not be so much of an issue because we can just apply more machines to that area that we want to do it with. Very similar to how the simulation works as well. So if there's not enough machines to give the processing power in there, we can spin up those machines and add the more processing power in there as well. And we do the same with the edge network as well. So we've not had that problem, but then it hasn't always been tested in anger. I mean, the biggest simulation we did was around 14,000 people connecting from 88 different countries. And the experience you got in America or in the UK or in Australia was similar. People really enjoyed their experience that they got. But of course, I'm sure there's someone who connected from Antarctica who probably didn't have a great experience, but I'm not sure. There needs to be a server near them somewhere, I guess.
Maybe it's not as complicated as it.
Yeah, but I mean, we've not had those problems. And like I said, that 14,000 people had that good experience. And just by finding the best computers for them at that time, solved that problem.
I have a question.
Yeah.
And just to follow up, in an example or in a universe away from gaming, in a corporate setting, one thing that we struggle with is a very similar problem, maybe at a smaller scale, right? In terms of understanding where all of our people are going to be and what they're going to be needing in that particular moment, whenever they touch down, wherever that is. And the way we compensate for that problem, because we don't have the ability to measure in real time where these people are and or project what it is they're going to be needing to do once they get there. What we do, which is an extraordinary and efficient thing, is we overspend
Absolutely.
in a tremendous way to put computing power at the edge, because we don't know where that edge is going to be. And inevitably, we find ourselves having to answer the question is, why is it that this computer doesn't work right? Well, it's a $4,000 computer. How can it not be working right?
Yeah.
The only thing that person might be doing is checking their email with it. But because I don't know where they're going to be or what they're going to want to do with it, I find myself having to spend millions of dollars on hardware that I know goes completely unused.
Yeah, no, absolutely. That's one of the things that we've targeted as well. Because the way we dynamically spawn processes and the way we dynamically spawn machines to run those processes on solves that problem. The limitation you've got is how quickly can you spin up a machine in the cloud. So some places take longer than others. I think, was it 15 minutes on Azure, I think was the current one. So you can have that lag, but we have ways that we can create a pool of machines that sit idle. And then as that pool empties, we can fill that up with more machines. So you can always refill that. That way you're only paying for the machines that you've actually got up and working at that one time. There's something else I was going to say, and I've completely forgotten what it was. But yeah, that is a significant problem. That part of our process, because we don't only dynamically scale up, we scale down as well. Once you've got all those machines up and you no longer need them, we can then take them out of the network, and then you won't be paying for them anymore. And that literally just empties that out. The time it takes to actually spin up a process is a fraction of a second. It is the time it takes to get a machine through a cloud and get that
How do you,
authorized.
how are you measuring? So I'm assuming that you are reacting to
yeah.
where the requests are coming in from, spawning machines up based on that.
There's multiple ways you can do it. If you think it'd take it from a gaming perspective, when you're running a simulation, you know everything your players are doing. You capture every single piece of information, so you can use information to predict what's likely to happen. And that way, once you've collected that information, you can say, right, at 9 o'clock on a Monday morning, we need to make sure we've got extra resources in this location, this location, this location, because that's what happens. And then you can go steps further when, for example, when a new update comes out, we need to make sure that the login servers have more and more resources applied to them, because that's when all the downloading is going to happen, and then that's when games fall over. And it's all the metrics that you can collect from how things are used that you can use then to start predicting what's going to happen next. And that's not what we don't do that prediction. We will help people get to the right resources to the right place, but there are plenty of other companies out there who will help with that prediction, that they will deal with that data and then say, right, this is how we build a simulation, or this is how we build something in order to get those resources to that point. But equally, it can be reactive, and it can be reactive based on the performance of the machines that you've currently got up. So as soon as they hit 50% full, you can start spawning up new ones, for example.
I have a question here.
Hi.
Hi. From a cost perspective, do you think it's better to build your own private cloud and run your simulation, or do you think it's better to use a public cloud out there and you just pay as you go?
I would not do pay as you go. I would get a contract with a private cloud, because your discounts are much bigger. It depends what you're doing. That's what it boils down. It depends on the simulation. If you're making a game, if you make a private cloud, you're buying machines yourself, so you've got that cost involved there. You've got to run those machines, you've got to pay for electricity and everything else on top of that. If you've got the resources to do that, there's sometimes that might be better because you can run it quicker. I mean, if you've got the bare metal yourself, potentially that could be cheaper, but then you are committing to that spend, even from a capital point of view. That's a cost that you've got. Not all companies can do that. Big companies can build their own data houses. A games company that wants to make a big MMO, but doesn't have, wants to make a big single world MMO, let's say, and doesn't have the resources to buy their own cloud and buy their own machines, they may well want to go to the cloud and do it that way. So it depends. It's so many reasons to do it. Some companies we've worked with have built it themselves. Some companies we've worked with have done it on the cloud. Some companies we work with have security reasons to not allow it to happen on the cloud, so we can work both off the cloud, on the cloud, whatever works for them. There is no straight, easy answer, I'm afraid. What are you thinking about? What sort of simulation were you thinking about?
I mean, like you said, it really depends on the application, right? The type of simulation you're doing, and also the size of the simulation, right? So I have another question, follow-up question. So obviously, if you can do it yourself, but do you think, because for Metaverse or any kind of 3D kind of simulation, it's very compute intensive and requires low latency. Do you think the general purpose clouds out there can deliver what you need, or do you think that we need to redesign, architect the infrastructure to meet your needs?
They can deliver what we need, but cost is the issue. The machines that we use, which give us the best performance, are the high performance machines, which obviously cost more than your bog standard machines. And from what I understand about cloud costs, it's the amount of machines that are available at any one time. And we've had conversations with some cloud people where they said, can we lay off doing big simulations at the time they have other things going on, because we can just take up that much resource when we do something big. And that's an issue for them. So I think in order to make the metaverse work, one of the things I can foresee happening in the future is the types of machines that become more predominantly available on the cloud will start changing. Rather than necessarily a super high compute machine, you'll start thinking about machines where the communication speed is quicker. high-performance communication machines as opposed to high-performance compute machines. It'd be great to have both, but I think that's going to get too expensive that way. And I think having lots of smaller machines making things work is going to actually be a better way of doing it than having less bigger machines making things work, which is why I think speed and communication speed becomes more of an important thing than necessarily compute.
Hey, I have a bit of a I have a question on your take on something. So like the use cases that I know from Hadian are mostly simulation related, right? Now, unfortunately, I work in a field that requires to get the latency down to a certain portion where I'm kind of breaking physics. It's graphics, of course, right?
Yeah, indeed.
And I've been thinking about scalability a lot lately, how to distribute graphics meaningfully. And one of the things that I stumbled across is this problem of if you're somewhat on the go, that relates to a different problem, which is, sometimes a node or a server that you use to compute something just fails and stops working. How you deal with that, because in my case, I want kind of like, the roaming for compute. Roaming is the thing that you have when you go on a high-speed train and your cell phone keeps working because it connects to other towers. I want that for compute, so I need to keep thinking about the problem, what happens to the nodes that shut off, and what happens to the nodes that come on dynamically, so that if I go with my phone along the street and there's like an edge network around me, I keep getting new compute resources, but others leave. Do you have a solution for this handover problem? How does it work in for instance, Hadian, if I suddenly add like 100 new nodes that work can be distributed to? Like how does the architecture deal with this?
Yeah, that's not a problem. There's two things here, right? So you've got your moving from node to node on your phone. A few years ago, I created a mobile game on the phone. We had exactly that same problem. It was an MMO, persistent game on the phone. And the way we dealt with it back then, this was for a different company that I worked for. The way we dealt with it back then, it still holds true now, is that you have to predict what's happening to make that feeling, that emotion, that experience you're getting seem consistent. So you're predicting where the person is going to, what's the next step to give you enough time to swap between one node that you're walking past to another node in order to make that happen, which means you've got to have stuff on your phone in order to do it. So you have to make sure stuff's downloaded onto the phone, make those predictions, and you get it wrong sometimes, and then the game will just do a weird thing, and then everything will connect again when you've connected to that new node. So that's that side of things. Just spawning 100 new nodes, 100 new connections to the simulation, that is absolutely fine. There's no problem with that. 1,000 people, I mean, to give you an idea of scale, we currently run around 10 million entities in a simulation, and we can just pile them in until, and that's, we stopped at 10 million. We didn't break at 10 million, we just decided to go no further, because who needs more than 10 million things in a simulation right now? So connecting nodes to it, connecting new things to it is not a problem. That immediately happens when something's needed. A process will spin up. That process will find a new machine. It will add the machine to it, and then it will just carry on working. We've got a manager system which allows you to understand where everything is. So what piece of compute connects to what part of the simulation, and that makes sure that all the information starts flowing around the right place. But if you were to put 100 nodes in, you wouldn't notice a difference. It would just continue working super smooth.
So is this, like you could argue it's sort of like a BitTorrent approach to scalability. The more, the better.
I don't know.
Does that work, or is there?
So,
So is there? Let's say, is there a limit? Like at what point, is the overhead of managing all the distributed compute systems?
The limit, I guess, the biggest limit you'll hit is cost. Because obviously new machines cost money, that's going to be a limit. There will be a limit, the curve isn't straight. But like I said, we've got to 10 million entities in one simulation, and we stopped because we had no reason to go any further. theoretically, it could go on forever, but obviously that's not always the case. For any use case you can come up with, I think we would be all right in that case right now.
All right, okay. I think I need to refine my question in the meantime. Maybe somebody else wants to take over.
Oh, yes. Yes, Bob.
I've got a question, and I've got a box. So you're talking about scaling, like basically resource servers, cloud servers. And I'm interested in metaverse experiences that are either entirely peer-to-peer between end clients, or they're hybrid peer-to-peer with maybe like one cloud server, maybe two. So like an architecture where a group of people get together to create a universe. And I could imagine scenarios where in order to manage physics and rules, the policy enforcement across the peers, they may need to agree to a centralized sort of back-end resource server to manage components of that universe. But there's a lot of interactions that they might coordinate directly with each other, like WebRTC, video calls, audio. There's pieces of the experience, the immersion that can be managed as a peer-to-peer solution. I wonder if there's been like much look at peer-to-peer metaverse sort of things generally. And I'm not saying like let's remove the server or node operation side completely from the problem, but what if we could limit it to just its primary value purpose in the system? Could we make the peers in the experience actually carry the universe a little bit more?
I would fully expect we could. We've not really gone down that route. I think that's not entirely true. So I guess when we were doing our last simulation, we did a whole bunch of work with PlayFab and communication between individuals, and that was peer-to-peer. So how much stuff can you take off out of the simulation itself in order to run peer-to-peer? So like I said, communication between chat boxes and voice, like you said. It's whoever builds that simulation can decide where that sits. We put the technology in there that allows you to scale it if you need to, but if you want to offload stuff, then that is completely doable. I mean, why would you not, I guess, is the thing, if you don't have to pay for that compute cost.
I want to chime in from my experience, not with building peer-to-peer metaverse, but trying to build a peer-to-peer CDN for live video. There are challenges with some mundane stuff like firewalls and asymmetric bandwidth that kind of ruin it all. And at the end of the day, you end up needing to rely on central capacity, traditional cloud, and you can practically, it's very hard to rely solely on this peer-to-peer, and it's nice to have. It can offload the central resources, but at the end of the day, you have to be ready for a situation where all your users are limited from doing peer-to-peer, and you need to rely on the central side. So you end up basically, so what we ended up in the startup I worked for is basically we kind of fell back to a traditional CDN where we had like co-locations with physical servers where we distributed the content. Now, not that people are not trying to do things. The recent one I heard is some kind of shared storage or peer-to-peer storage. So people are still trying, and the technology is evolving. Firewalls of today are not the firewalls I dealt with 15 years ago, and there are technology for traversal, but it is a bit challenging to do this peer-to-peer, especially for high volume of traffic like Metaverse or something like that.
And you've got the persistent side as well, I guess, haven't you? Because if you're thinking about the Metaverse, the persistence of it as well, how do you make sure that what's happening in a peer-to-peer network actually relates back to that Metaverse? At some point, you need this single source of truth of what the Metaverse is, where everybody is at one point in that simulated part of the Metaverse that you're in. A peer-to-peer for that, I don't think it's necessarily going to work that closely with that. That would be, it's got to be server. The server's got to say what's happening. As soon as you have something where you can inject something in via the client, which doesn't have to be checked by the server, that's when you get all sorts of nightmares happen. And if you've made games, you'll know exactly what can happen at that point. But I think a whole bunch of stuff which is not critical can be offloaded. communication certainly is a way of doing that. That's again if you don't want to moderate that communication, because that's the other side of things as well.
The use case that I'm thinking about is definitely not for, large universes with, lots of people. It's more like 4 or 5 people who've opened a particular unguessable URL for a short period of time. And there might even be high degree of trust between these peers. They might have strong relationships either in the physical world or at one point they were, physically present together. And so there are a whole bunch of security issues that come from trusting peer connections to carry, authoritative information for a universe. But if these are, your family members, it could be a slightly different scenario. I'm definitely not thinking about really large-scale interactions.
Yeah, indeed. So yeah, so kind of like a CS:GO server for you and your mates. Yeah, that's fair enough. That's cool.
I was curious about, in thinking about scaling up, how stuff also gracefully scales down in places where the bandwidth is really low. Are they just going to have dotted lines where people should be, or I guess in the other BoF, or in the earlier session we were talking about is this all going to come to everybody and when is everyone getting it? But I think there's going to be some unevenness. I don't know if people have been thinking about what that unevenness looks like. Will it be we're all Vampire Diaries, and in certain places, it looks like Tom and Jerry still, or is there a more graceful way to kind of step that down when the bandwidth is low?
I think it's going to be different for different people. I mean, the bandwidth is your big problem. The last mile connection is a big problem for how we're going to get to a place where everyone can have exactly the same experience. How can we deal with that? There could be a client-side solution to that, so the core information is kept as minimal as possible, and you're only sending the absolute minimal information you can to that end user, and then it constructs it on their device using the stuff that the client they've downloaded in the way they're doing it, and the client will depend on the machine that they've got as well. So if you've got the central simulation of the metaverse working, that is always the same, that's always got the same information. How that looks could be different per machine. So if you've got, I don't know, think of an example of a client. You've got a client which is like a Tom and Jerry client, then everything could look like Tom and Jerry. Or if you've got a client that looks like I don't know what Vampire Diaries is. I'm sure it's that my daughters watch.
It's a little more sophisticated looking than Tom and Jerry. That's
okay,
all.
fair enough.
I just picked it out of the air.
But if you've got a Vampire Diary one, then I'm sure that everything could look like vampires if you wanted to, because the way you display it on your screen can equally be handled by what's happening on your machine at the time and what's in your client.
So maybe things that are optimized for areas where a lot of people have fairly low bandwidth might have a lot of reusable elements that they keep locally, and then just the mouse and the cat move around, but the rest is just sitting there.
Yeah, absolutely. But that creates the bigger problem of, if I'm in the metaverse, I've created something, I then want to be able to share it with you. Like Royal was saying earlier, we're not going to shut down the metaverse so you to reboot it again. How do you take that information and then render that directly on someone's machine? And that could happen 1,000 times a second because you've got 1,000 different things stood in front of you, which aren't on your machine because you've had no way to download them because you didn't know they existed until just that second that you saw them. And that, I don't have a solution for that.
Yeah, I'm just wondering because it might turn out to be a place where you have the cheap lobby where you're not going to get so many new elements because you know that your environment can't handle it, and then the fancier end where you have all the bandwidth you want.
Yeah,
so.
I think you're probably right. Yeah, I think you're probably right. Fortunately, I live in a little village which has lots of bandwidth because nobody else knows how to use the internet where I live.
Not everyone can afford to live in San Francisco, right? So, or somewhere with that kind of bandwidth.
Yeah, indeed. No, I think you're right. How much time have we got left? I think I had a... Are we? Okay, wonderful. Any last questions before I go? Oh, beautiful. Thank you very much.